Hello and welcome to today's lesson on breathing mechanics. This is kind of a two-part section of our notes, so we're going to split it in two pieces. This is part one. We're looking at lung volumes and capacity, so terms we give for the amount of air that's held in your body at any given time. We have volumes and capacity. We're going to talk about both of those. So with this, you will be able to distinguish between what's known as inspiration and expiration. So not inspiration like, I want to do that. You've inspired me. Different. This is anatomy and inspiration. It will be able to describe the changes our body makes in order for us to breathe. We're going to talk about 4 respiratory volumes and 4 respiratory capacities. And these capacities are going to include the 4 volumes, so it's all the question of which ones go where. So for starters, we talked about ventilation. Ventilation is breathing in and breathing out. So when you breathe in, you breathe air into your body, you inhale air. This is known as inspiration. And when you exhale, this is known as expiration. So the words kind of go together, but you will need to be able to understand and differentiate between these two words. When we talk about inspiration, the atmospheric air pressure, when this happens, your air pressure, the pressure outside of our bodies, is enough to move air into the lungs. And so when your lungs are relaxed, when they're not doing anything, air is just resting, that's when your pressure inside, pressure outside is the same. And so if you're breathing in, the pressure outside is greater. If you're breathing out, the pressure inside is greater. Okay, so as your volume gets bigger, the pressure inside your lungs decreases and air comes into the body. When you breathe out, what you're doing is you're decreasing the space in your lungs, which forces air out because the pressure is increased. And so this is just like a plunger. We're going to do a demonstration on this in class so you can kind of see how this works a little bit. But a plunger is a great example. You pull the syringe out and air comes in, you push it up, increase the pressure, air, whatever fluid you had, goes out. And so that is how this works. Okay, the key component to you breathing is your diaphragm. You have 2 sets of muscles, or 2 groups with your diaphragm. Your anterior group originates from the ribs and sternum, and then your posterior group originates from the vertebrae. Okay, so these are the muscles that control your breathing. And your diaphragm is controlled by this thing known as the phrenic nerve. We'll talk about the nervous system at the end of the year. But the phrenic nerve controls your diaphragm, controls your breathing. When your diaphragm contracts, your intercostal muscles contract and lift your ribs up, and this decreases the pressure in your lungs. So your diaphragm contracts and moves down. This is showing you here. These arrows show you the diaphragm is going down, which increases the space between your the superior portion of your ribs and your diaphragm. So increases the volume. We also have muscles in your ribs that pull them up and out, which also increases the space. When this happens, your volume goes or your pressure goes down. Volume goes up, pressure goes down. And so because of that, your atmospheric pressure, the pressure outside, is greater than the pressure inside. So if your mouth is open, your nose is open, nasal cavity is open, air is going to come in and fill that space. So it's all based on pressure differences. These are the major events of inspiration, that your impulse travels on the phrenic nerve, contracting your diaphragm. And then as your diaphragm moves down, your thoracic cavity expands, your ribs are pulling up, expanding the thoracic cavity more, your pressure drops, atmospheric pressure is greater, air goes into the lungs fill with air. I'm not going to ask you these 6 steps. How do you breathe in exactly 6 steps? No. But this is the basics behind how it works. Okay? So again, here's another picture showing you the different muscles that are contracting and pulling your body in different ways. And so you have different muscles pulling on different parts of the body, increasing that volume and allowing your lungs to fill with air. And so when this happens, you have ventilation happening, air is moving in and out. The question is, what keeps your alveoli from collapsing when your pressure drops in the lungs? Because we talked previously that your trachea would collapse without the cartilage because The high pressure would collapse the low pressure, and the same situation would be here. How do your alveoli not collapse when you breathe out and the air leaves your lungs? And what happens is they are surrounded by this thing known as surfactant fluid. This is a fluid that surrounds your alveoli and sticks together, which keeps that space open. It creates that opening that doesn't get closed and allows air to go in and out all the time. It does not close with a vacuum. And so that surfactant fluid keeps your alveoli open, which is good for you. When you breathe out, so that was all breathing in. When you breathe out, this is when the force inside your body is greater than the force outside of your body. And so this happens when your diaphragm relaxes. It then lifts up and increases the pressure in your lungs. Your internal abdominal organs push the diaphragm up, further decreasing the volume, forcing air out. Your intercostal muscles relax, which allow your ribs to go back down, which again decreases the space and increases the pressure in your lungs, forcing air out of your body. So these are your steps for expiration. Okay, if you need to exhale more than normal, you have your intercostal muscles that can contract and pull your ribs down farther. You also have abdominal walls that contract and push your diaphragm up further. But the basics behind expiration, your diaphragm and external respiratory muscles relax. So things relax actually for you to breathe out. Your elastic tissues of the lungs and thoracic cage recoil and decrease that space. Tissues around the lungs increase your pressure. Air is forced out because it's greater than the pressure on the outside. So again, I'm not going to ask you to list these 4 steps in order, but just so you have a kind of a step-by-step, here's how you breathe out, here's why you breathe out. Okay? And then so with all of that, we have these things known as volumes and capacities. And so when you go through what's known as a respiratory cycle, you have 1 inspiration, 1 breath in, and 1 breath out. And with that, you have 4 different volumes that are going to be discussed, you can have measured. And so these 4 volumes, the first one's called your tidal volume. Tidal is the amount of air that enters or leaves the lungs during your respiratory cycle. This is known as this is if you would breathe normally. So you're sitting and watching this video, breathing normally. That is known as your tidal volume. The volume that goes in and out in 1 normal breath in, 1 normal breath out. This is roughly 500 milliliters of air. It goes in and out in a normal cycle. Okay, we also have this inspiratory reserve volume. So inspiratory being we're breathing in, reserve being extra, volume being space. This is an additional volume that can be forced in when you try to take a deep breath. And you can breathe in, this is roughly 3,000 milliliters or 3 liters worth of air. That's a lot of air. Okay, but 3 liters worth of air you can breathe in extra on top of this 500 residual. Okay, so now when you breathe out, we also have this expiratory reserve volume. So normal breathing in and out is your tidal. We can also force extra air out of that. And so this is the volume that can be expelled with maximum force. And so you can take a normal breath in and you can push extra air out. That's this expiratory reserve volume. And that kind of varies depending on the person. But then we have the last little bits, our residual volume. This is the amount of air that you cannot get out of your lungs. It's always in there. It may interchange, and it may not be the same exact air particles all the time, but the same quantity of air has to remain in your lungs, or your lungs will collapse. Regardless of the surfactant fluid or anything else, they're going to collapse if you have less than roughly 1,200 milliliters of air in your body, your lungs will collapse, which is not good for you. Okay, so here's a diagram. You will need to be able to label a diagram similar to this for me in this course. So again, this is your tidal volume, the normal up and down volumes. If you take a deep breath in, this is your inspiratory reserve volume, the extra reserve space that you have for air. If you push extra air out, this is your expiratory reserve volume. Extra being reserved, you push out. And then this bottom piece, this is the stuff you cannot push out. This is your residual volume. And we'll talk about capacities here in a second. But these are your volumes that you need to be able to identify on a picture similar to this. Okay, now if we talk capacities, you have an inspiratory capacity, the capacity of air that you can breathe in, which would encompass your tidal volume, which you breathe in normally, plus your inspiratory reserve volume. And this is the maximum amount of air that you can breathe into your body, is here. Okay? The opposite of that is your functional residual capacity. So this is what can be left after a normal breathing out cycle. So you would have your residual volume, stuff you can't get out, plus your expiratory reserve volume. So this is, again, after a normal relaxed expiration, this is the amount left, is your functional residual capacity. Your vital capacity is the maximum amount you can force in and out. So if you take a deep breath in, deep breath out, this is your vital capacity. So deep breath in, inspiratory reserve volume, plus your normal breathing in and out, your tidal, plus all the air you can force out, which is your expiratory reserve volume. So these three volumes make up your vital capacity. And then the last one is your total lung capacity, which is the easiest of them all because you just add them all up. Inspiratory reserve volume, tidal volume, expiratory reserve volume, and residual volume. All added up, that's your total lung volume. So again, here's our diagram. Your vital, let's start total lung capacity. You see these arrows go top to bottom. You have your residual volume, your expiratory reserve volume, your tidal volume, and your inspiratory reserve volume. We have your inspiratory capacity. So again, breathing in, how much air can you breathe in? Which is your tidal plus your inspiratory reserve volume. Your functional residual capacity fills in the rest of that. So your inspiratory capacity plus your functional residual capacity equals your total lung. So if these all breathe in, this is all the extra stuff left over. And then your vital is everything except your residual volume down here at the bottom. Okay, so again, you will need to be able to identify those for me in this course. Okay, here are some end of the section review questions. Take a look at these. If you have questions on them, please ask. These are great review questions to help you kind of practice your different volumes and capacities. And again, we will discuss this more when you return, but make sure you come somewhat prepared and having an idea of what we're talking about here. If you have questions, let me know. If not, enjoy the rest of your day, and I will see you when you return to school. Goodbye.